Welcome to Review Central's penultimate SAT and ACT Cram-Time reviewer for mathematics. This reviewer is intended for those who are set to take, and are running out of time to review for, the SAT or the ACT. This reviewer covers the mathematics sections of both the SAT and the ACT. There are 50 plus 1 carefully curated questions featured on this reviewer. All questions are modeled on actual questions that appeared on previous SAT and ACT mathematics tests. By the way, please note that this video reviewer is best watched with your device's audio turned on. Before we proceed, don't forget to subscribe to Review Central and click or press the bell button to make sure you get notified whenever we post a new reviewer or other review materials on this channel. Now let's begin. Question number 1. If u plus t equals 5, and u minus t equals 2, what is the value of the quantity, u minus t times the quantity, u squared minus t squared? A. 20. B. 10. C. 5. D. 2. The correct answer is A. 20. The tendency of most test takers is to add the equations, u plus t equals 5, and u minus t equals 2, to first solve for u and then solve for t. A better and much faster solution is to first recognize that u squared minus t squared is what is known as the difference of squares, which is equal to u plus t, multiplied by u minus t. U plus t and u minus t are already both given as 5 and 2 respectively, so the solution is simply 2 times 5 times 2. 2 times 5 times 2 is equal to 20. Done. Question number 2. What is the area of the shaded region in the given figure? A. 48 minus 12 times pi square inches. B. 48 minus 24 times pi square inches. C. 54 minus 6 times pi square inches. D. 54 minus 12 times pi square inches. The correct answer is A. 48 minus 12 times pi square inches. The first step is to recognize that the area of the shaded region is equal to the area of the rectangle minus the total of the areas of the 12 inscribed circles. Agree? The area of the rectangle can simply be computed as 8 inches times 6 inches, that is, its length times its width, or 48 square inches. But what about the areas of the 12 inscribed circles? First of all, let's establish some fair assumptions. The circles must be identical and are perfectly tangential to each other and to the rectangle enclosing them. Being so, then we can say that the diameter of each circle must be 2 inches, since the width of the enclosing rectangle is 6 inches and there are 3 circles stacked one over another. The 2-inch diameter is also validated by the fact that the length of the rectangle is 8 inches and there are 4 circles side by side from left to right. With the diameter of each circle being 2 inches, the radius of each circle must be 1 inch. Now we can compute for the total area of the 12 inscribed circles as 12 times the area of each circle, or 12 times the square of the radius times pi, or 12 times 1 squared times pi, or simply 12 pi. And the area of the shaded region should be 48 minus 12 pi. Done. Question number 3. What is the y-intercept of the graph of y minus 4 raised to x in the Cartesian plane? A. The coordinate x equals 1 and y equals 4. B. The coordinate x equals 1 and y equals 0. C. The coordinate x equals 0 and y equals 1. D. The coordinate x equals 4 and y equals 1. The correct answer is C. The y-intercept is the point at the coordinate x equals 0 and y equals 1. This is a slope-intercept problem made a little bit complicated by the presence of a variable exponent in the equation of the graph. Apparently, many SAT and ACT test takers find this combination of slope-intercept and variable exponent to be very scary, so much so that many test takers who encounter a problem like this in the SAT or the ACT decide to quickly skip it. That's very unfortunate for them because, in reality, this is a giveaway question, at least in our opinion. And here's why. The problem asks for the y-intercept given the equation y is equal to 4 raised to x. Regardless of how complicated looking the given equation may be, by definition, the y-intercept is simply the value of y when x is 0. A quick inspection of the answer choices will actually eliminate all the choices except answer choice C, 0, 1, since it is the only choice with x equal to 0. A real giveaway, right? So even without giving any attention to the complicated-looking equation, those who got scared and immediately skipped this question could have easily answered it correctly just by inspecting the answer choices. Nevertheless, let's demystify the seemingly scary equation if only to prove that its y-intercept is indeed the point 0, 1. Okay, so we have the scary-looking equation, y equals 4 raised to x. To find its y-intercept, we set x to 0. Y equals 4 raised to 0. Any number raised to 0 is equal to 1. Hence, y equals 1. Therefore, the y-intercept is the point, 0, 1. That's not too hard, is it? In fact, it is almost as simple as just inspecting the answer choices, in our humble opinion, that is. Question number 4. Find the value of x in the given figure. A. 15 degrees. B. 12 degrees. C. 10 degrees. D. 8 degrees. The correct answer is B. 12 degrees. Recall that when a circle is sliced into any number of pies, the angles of all the pies must equal 360 degrees. In our given figure, the angle of the biggest pie is given as 240 degrees, and then there are 10 smaller pies that are x degrees each. Therefore, 240 plus 10x equals 360. From here we simply solve for x, which is equal to 12 degrees. Done. Question number 5. Find the value of y given that 10% of 3y plus 1 is 10. A. 11. B. 33. C. 66. D. 99. The correct answer is B. 33. Step 1. Write his equation. 0.1 times 3y plus 1 equals 10. Step 2. Multiply both sides by 10. Step 3. Subtract both sides by 1. It is now 3y equals 99. Step 4. Divide both sides by 3. And we're done, with y equals 33. Question number 6. Solve 8 divided by 2 times the quantity 2 plus 2 squared. A. 256. B. 64. C. 0.25. D. 0.125. The correct answer is B. 64. This is a simple question to test that you know your correct order of operation. So let's solve it following the correct order of operation based on the PEMDAS rule. You do recall your PEMDAS rule, right? Okay, just in case you've forgotten all about it, it is the rule for the order of operation in basic arithmetic. It stands for parentheses, exponents, multiplication, division, addition, and subtraction. It is known by many different names in different parts of the world. It is also called PEDMAS, BEDMAS, BIMDAS, BIDMAS, BIMDAS, BODMAS, BOMDAS, and so on, but they are all basically the same. Okay, let's proceed to solve this problem, and for sure PEMDAS will all come back to you. Going back to our given problem, let's now apply the PEMDAS rule. Step 1. Resolve the parentheses first, 8 divided by 2 times 4 squared. Step 2. Resolve the exponent next, 8 divided by 2 times 16. Step 3. Since what remains are all division and multiplication, solve from left to right, that is 8 divided by 2 is 4, and then 4 times 16 is 64, our answer. Done. Question number 7. 101 squared minus 99 squared is equal to A. 4. B. 40. C. 400. D. 4000. The correct answer is C. 400. Your initial tendency might be to proceed to square 101 and then square 99 and then get their difference. Of course, this will also give the correct answer. The problem is that unless you are allowed to use a calculator, which you probably aren't for this particular problem, otherwise, what's the point, right? Getting the squares of 101 and 99 can be very challenging, don't you think? Actually, the solution to this problem is quite simple even without using a calculator, if you know the underlying algebraic principle, that is. To solve this problem simply, you first need to recognize that this is what is known in algebra as the difference of squares. Now recall that given two squares, say x squared and y squared, their difference, x squared minus y squared, is equal to x plus y multiplied by x minus y. Now, let's substitute 101 for x, and 99 for y. 101 squared minus 99 squared is equal to 101 plus 99 times 101 minus 99. This should result to 200 times 2 or 400. And we're done. Question number 8. Convert 2 times pi over 3 radians into degrees. A. 120 degrees. B. 100 degrees. C. 90 degrees. D. 60 degrees. The correct answer is A. 120 degrees. Well, either you know your radians to degrees conversion or you don't. You don't? Seriously? It's very simple and easy to memorize actually. Angles in radians are usually expressed in terms of an integer, or more often a fraction, multiplied by pi. Just substitute pi with 180 and proceed to simplify the fraction. In our given problem, 2 times pi over 3 is equal to 2 times 180 over 3 is equal to 360 divided by 3 is equal to 120 degrees. Done. Question number 9. In the figure above, find x plus y. A. 190 degrees. B. 210 degrees. C. 230 degrees. D. 270 degrees. The correct answer is C. 230 degrees. There are different ways to solve this problem, probably the fastest among them is by applying the exterior angle theorem. You do recall your exterior angle theorem, right? No? Let's do another quick review then. The simplified definition of the exterior angle theorem is that the exterior angle of a triangle is equal to the sum of the opposite two interior angles. In our given illustration, the exterior angle E of triangle ABC is equal to the sum of the interior angles A and B. It's as simple as that. In our given problem, applying exterior angle theorem on the left, or smaller, triangle, we can quickly figure out that x must be 120 degrees. That is, 80 plus 40 equals 120. Next, let's apply opposite angles theorem to establish that the angle in the bigger triangle that is opposite of the 40-degree angle in the smaller triangle should also be 40 degrees. Again, using exterior angle theorem on the bigger triangle we should quickly figure out that y must be 110 degrees, that is, 70 plus 40 equals 110. Finally, x plus y equals 120 plus 110 equals 230. Done. Okay, but let's just say that you really do not know exterior angle theorem. Even if you do not know exterior angle theorem, you can still quickly figure out x by first finding the third and missing angle of the left triangle. Since the sum of the interior angles of any triangle must equal 180, the missing angle should be 180 minus 40 minus 80 equals 60. X and 60 are supplementary angles, therefore x plus 60 equals 180. X equals 180 minus 60, or 120. Similarly, we can find the remaining missing angle of the bigger triangle by subtracting 70 and 40 from 180, and get 70. This second 70-degree angle is a supplementary angle of y. Therefore, y equals 180 minus 70 equals 110 degrees. And again, the only remaining step is to add x and y and arrive at 230. This second solution is a bit longer and may cause you an extra 3 to 4 seconds, but that isn't too bad. Try and regain 3 to 4 seconds in the other problems, okay? Question number 10. 60% of what number is 30% of 60? A. 18. B. 24. C. 30. D. 36. The correct answer is C. 30. Let x be the number we are looking for. 60% of what number is 30% of 60? Therefore, 60% of x is equal to 30% of 60. In equation form, 0.60x equals 0.3060. From here we can simply solve for x, and should quickly arrive at x equals 30. Done. Did you notice something peculiar with this percentage problem? 60% of 30 equals 30% of 60. The percentage and the number it is applied to can be swapped and they will still result to the same number. This is always true for percentages. Try it yourself with other percent and number combinations. 40% of 25 equals 25% of 40. 12% of 35 equals 35% of 12. 200% of 11 equals 11% of 200. And so on. Amazing, right? Question number 11. A function f satisfies f of 2 equals 3, and f of 3 equals 5. A function g satisfies g of 3 equals 2, and g of 5 equals 6. What is the value of f of g of 3? A. 6. B. 5. C. V. D. 2. The correct answer is C. 3. This may look a bit complicated, but in reality it is a very simple problem, like most SAT and ACT problems. The function g of 3 is already given as 2. Therefore, f of g of 3 is simply f of 2, which is also already given to be 3. The other given values, f of 3 equals 5 and g of 5 equals 6, are actually not needed in solving the given problem and are simply meant to confuse us. Question number 12. Three numbers are in the ratio 3:4:6. If the middle number is 28, what is the sum of the three numbers? A. 84. B. 91. C. 98. D. 105. The correct answer is B. 91. There can be several ways to solve this problem. Let us introduce you to a handy and cool technique, in case you are not familiar with it yet, to solve ratio and proportion problems like this. We call it, for lack of imagination, the box method. Let's represent the given ratios as boxes, as shown. All of the boxes represent the same number. Since we know the middle number to be 28, we divide it with the number of boxes representing the middle number. That is 4. 28 divided by 4 equals 7. Therefore, each box must contain a 7. The first number has 3 boxes. 3 by 7 equals 21. Therefore the first number is 21. The third number has 6 boxes. 6 by 7 equals 42. Therefore, the third number is 42. The sum of the three numbers should be 21 plus 28 plus 42 equals 91. Or we simply multiply 7 by the total number of boxes, which is 13. 13 times 7 equals 91. Question number 13. If the day before yesterday was Wednesday, what day will be 2 days before tomorrow? A. Tuesday. B. Wednesday. C. Thursday. D. Friday. The correct answer is C. Thursday. We actually don't need any math skills to solve this problem, just good old common sense and some nifty tricks to jot down and remember days of the week. Or a calendar, although we are probably not allowed to bring and use one in the SAT or the ACT. Let's process this one sentence at a time. The day before yesterday was Wednesday. That makes yesterday Thursday, today Friday, and tomorrow Saturday. What will be 2 days before tomorrow? That will be 2 days before Saturday. In other words, Thursday. Question number 14. As part of a science experiment, a ball was dropped and allowed to bounce repeatedly off the ground until it comes to rest. The graph above represents the relationship between the time elapsed after the ball was dropped and the height of the ball above the ground. After it was dropped, how many times was the ball at a height of 480 centimeters? A. 1 time. B. 2 times. C. 3 times. D. 4 times. The correct answer is C, 3 times. Many test takers tend to be scared of questions involving graphs. Oftentimes, when they see a graph, especially one accompanied by a relatively long text just like this one, they immediately tune out and decide to simply skip the question. Well, that's unfortunate for them, so don't be like them, because in reality, questions like this are among the easiest to answer in the SAT and ACT. In fact, for this particular question, just like in many similar ones, you don't even need to make any calculations. You simply need to read the text, understand the question, and simply pick out the answer from the graph. The answer is literally there, hiding in plain sight. Let's answer this question and show you how easy it really is. The question is, how many times was the ball at a height of 480 centimeters? The only real calculation we need to do, and we can do it in our head, is converting the height from meter to centimeters. The height in the graph is given in meters, or fractions of a meter, and we are being asked how many times the ball is at the 480 centimeter level, so we simply need to convert 480 centimeters into meter, which is 0.48 meter. The height in the graph is given in 0.2 meter intervals, so we can simply estimate the 0.48 meter level. On the graph, we can simply draw a horizontal line from our estimated 0.48 meter mark. For our last step, we simply count how many times our 0.48 meter horizontal line intersects with the line representing the bouncing ball. How many times did they intersect? 3 times, right? So the answer is 3. Question number 15. What is the remainder of 3,500,050,301,001 divided by 9? A. 8. B. 5. C. 3. D. 0. The correct answer is D. 0. This is another SAT favorite. This problem involves a ridiculously large number. Surely, we are not expected to be able to solve this without a calculator, are we? Actually, we can solve this without a calculator. There's a special characteristic of numbers that are divisible by 9, and as long as you know this special characteristic, you should be able to solve any similar problems regardless how ridiculously large or unusual the numbers are. Here's how this works. If presented with a ridiculously large integer that is divided by 9 and you are asked for the remainder, all you need to do is to pick out all non-zero digits, add these, and divide the sum by 9. Whatever the resulting remainder is the same remainder of the original number divided by 9. Sounds weird and unbelievable, right? But it is true. Try it. In our given problem, let's pick out the non-zero digits. These are 3, 5, another 5, another 3, 1, and another 1. Now let's add them as follows. 3 plus 5 plus 5 plus 3 plus 1 plus 1 equals 18. Next, we divide the sum by 9. 18 divided by 9 equals 2 remainder 0. And lastly, we simply pick out the remainder from the quotient. The remainder is 0, therefore the correct answer is 0. Check with a calculator if this is correct. Of course it is. You may say that this is just a coincidence, so let's try another ridiculously large number, just for fun. For easier comparison, let's base the new number to the one in our given problem. We can choose to change any combination of numbers. We can even choose to change some of the non-zeros to 0, and vice versa. But for the purpose of simplifying our illustration, let's just try to change 3 of the non-zero digits by adding 1 to each of them. This should result to a sum of 21, which if we divide by 9 should equal to 2 remainder 3, correct? Now validate with a calculator if indeed your new number will yield a remainder of 3. Of course it will. A caveat though. Depending on our calculator, we may get decimal answers of 0.33, 0.333, 0.3333, etc. when we divide the sum of the non-zero digits by 9. And when we multiply this by 9 to get the remainder, we may arrive at a non-integer answer such as 2.997 or 2.9998. That's just decimal truncation error from the infinitely repeating 0.333, so we simply round up our final answer to 3. Question number 16. If the arcs have a radius of 3 inches, what is the area of the shaded region? A. 36 minus pi. B. 36 minus 3 pi. C. 36 minus 6 pi. D. 36 minus 9 pi. The correct answer is D. 36 minus 9 pi. Since all the arcs have a common radius of 3 inches, then the sides of the square must be 6 inches each, correct? Therefore, the area of the square must be 6 squared, or 36 square inches. But we are asked for the area of the shaded region only. If you look at each arc bound by the half sides of the square, you will realize that each is a quarter of a circle. Since there are 4 of them, then their areas should be equal to the area of one whole circle with a radius of 3 inches. Knowing the formula for the area of the circle to be pi r squared, we can quickly solve for it to be pi times 3 squared, or 9 pi. Therefore, the area of the shaded region should be the area of the square, which we determined earlier to be 36, minus the area of a circle with radius of 3 inches, which we determined to be 9 pi. Question number 17. Find the limit as x approaches 3, of the expression, the quantity x squared minus 4x plus 3 over the quantity x squared minus 9. A. 1/3. B. 1/2. C. 0. D. 3. The correct answer is A. 1/3. Calculus problems do find their way into the SAT and ACT from time to time, but very, very seldom. After all, what is calculus but just a more advanced topic in algebra? Anyway, if they do, they are usually just very simple calculus problems, just like this one. When you see a problem like this, where you are asked to find the limit of a given algebraic expression, then you have in front of you one of those rare calculus problems in the SAT or ACT. Don't panic. As we already mentioned earlier, even if you find a calculus problem in the SAT or the ACT, it is almost guaranteed that it is but a very simple problem to solve. The first step is always to simplify the given expression. The numerator is a quadratic equation. We factor it out into x minus 1 and x minus 3. The denominator is a difference of squares expression. Recall that the difference of two squares can be expressed as the product of the sum and difference of their bases. That is, x plus 3 times x minus 3. Simplifying, we should quickly get our answer, which is 1/3. You may ask, why not simply substitute x with 3 immediately in the original equation? Well, you can go ahead and give it a try and then you'll know why. If you immediately substitute x with 3, you will find out that you'll get a 0 both in the numerator and the denominator. 0 over 0 is not equal to 0, by the way, so don't make the mistake of choosing option C as your answer based on this. 0 over 0, or any number divided by 0, is what is known as undefined in mathematics. You will get an error if you attempt it in your calculator. Whenever you get a divided by 0 answer in your finding the limits calculus problem, you'll know that you have not found the solution yet. It means you have not yet properly simplified your expression before substituting the variable with your limit value. Or that you possibly made an error in simplifying the expression. Question number 18. What are the solutions to the equation above? The equation as shown is, the absolute value of the quantity 9 minus 2x equals 3. A. minus 2 and 3. B. 0 and 4. C. 1 and minus 1. D. 3 and 6. The correct answer is D. 3 and 6. Whenever we see a number or an expression in between two vertical lines such as in our given problem, we know that we are dealing with absolute values. All we need to remember whenever we see the absolute value symbol is that the result of an absolute value operation or symbol is always positive, regardless if the number or expression inside the symbol is positive or negative. Therefore, in our given equation, the expression inside the absolute value symbol can either be 3, that is positive 3, or negative 3, to satisfy the equation. So to find the solutions to the equation, we equate 9 minus 2x to both 3 and minus 3. Let's start with 9 minus 2x equals 3. Solving for x, we should quickly arrive at x equals 3. This is the first solution. This effectively eliminates answer choices B and C, since they do not include a 3. Next, 9 minus 2x equals minus 3. Again, solving for x, we should this time arrive at x equals 6. This is the second solution. Therefore, the correct answer is D. Question number 19. In the triangle below, what is the value of A? Note that the figure is not necessarily drawn to scale. A. 7. B. 7 square root of 2. C. 7 square root of 3. D. 14 square root of 3. The correct answer is C. 7 square root of 3. Since the given triangle is a right triangle, and one of its other angles is also given to be 30 degrees, then we know that this must be a 30-60-90 right triangle. Recall that in a 30-60-90 right triangle, the ratio of the lengths of the sides is x, is to x square root of 3, is to 2x, where x is the length of the shorter leg, x square root of 3 is the length of the longer leg, and 2x is the length of the hypotenuse. We often see these expressed as the ratio 1 is to square root of 3 is to 2, which is the case when x equals 1. In our given figure, the hypotenuse is given as 14. Hence, 2x equals 14, and x equals 7. Therefore, the length of the shorter leg, which is x, is 7. On the other hand, the length of the longer leg, or a, is 7 square root of 3, which is what we are looking for. Question number 20. If a squared plus b squared equals 4 and a times b equals 5, what is the value of the quantity a plus b squared? A. 14. B. 9. C. 8. D. 4. The correct answer is A. 14. Problems like this abound in the SAT, as well as in the ACT. They can seem complicated and intimidating, but in reality they are ridiculously very simple and quick to solve. First, let's expand the quantity a plus b squared to a squared plus 2 times a times b plus b squared. Next, we simply rearrange the resulting expression as follows: a squared plus b squared plus 2ab. A squared plus b squared is already given as 4, and ab is also already given as 5, so we just substitute these to our expression. 4 plus 2 times 5 equals 14. Ridiculously simple and very quick to solve, right? Question number 21. What is the sum of all the factors of 24? A. 48. B. 56. C. 60. D. 72. The correct answer is C. 60. For this problem we don't have much choice but to determine and list down all the factors of 24 as follows. 1 times 24. 2 times 12. 3 times 8. 4 times 6. These are all the factors of 24, right? Adding them all up, 1 plus 2 plus 3 plus 4 plus 6 plus 8 plus 12 plus 24 equals 60. Question number 22. Solve. Square root of minus 2 times square root of minus 8 equals A. minus 4. B. minus 2 times square root of 2. C. 2 times square root of 2. D. 4. The correct answer is A. minus 4. Most test takers get this wrong. Let us first show you how most test takers solve this the wrong way. Compare it with the way you would solve it yourself. Do you solve this problem in the same way? If yes, then you'll get a wrong mark for this question too. Okay, so here's the common but wrong solution to this problem. Step 1. Combine minus 2 and minus 8 inside the radical. Step 2. Multiply minus 2 and minus 8, resulting to positive 16. Step 3. Get square root of 16, which is 4. Easy and quick, right? Yes, easy and quick, but wrong. So don't solve it this way. Here's the correct solution. Step 1. Factor out minus 1 from minus 2 and minus 8. By definition, square root of minus 1 is an imaginary number with notation I. Step 2. Multiply the two i's together. They become I squared. Step 3. Now we can put 2 and 8 together inside the same radical. Step 4. Multiply 2 and 8 to get 16. Step 5. Get square root of 16, which is 4. Step 6. By definition, I squared is equal to minus 1. Therefore, minus 1 times 4 equals minus 4. This is the correct solution and answer. Question number 23. 27 men can do a certain job in 15 days. In how many days can 18 men do it? A. 22.5 days. B. 23 days. C. 23.5 days. D. 35 days. The correct answer is A. 22.5 days. To compute for the work done, we simply multiply the time worked by the number of men who worked to complete the job. Therefore, for our first scenario, the work done, W1, is equal to 27 times 15. We use the same formula to compute for the work done, W2, for the second scenario. There are 18 workers to do the job, but we don't know how many days they require to finish the job. Let X be the number of days for the 18 men to complete the job. Therefore, W2 equals 18X. But take note that the job is the same for both scenarios, so we can equate W1 and W2. Therefore, 27 times 15 equals 18X. From here we can quickly solve for X to be 22.5 days. A little test of reasonableness can be used to validate our answer. Since the number of men was reduced from 27 to 18, we can expect that the number of days to complete the same job should increase. From 15 days it increased to 22.5 days. Sounds quite right, right? Question number 24. If 3p minus 2 is equal to or greater than 1, what is the least possible value of 3p plus 2? A. 5. B. 4. C. 3. D. 2. The correct answer is A. 5. This is one of those math questions that, for some reasons, stump a lot of test takers in the SAT and the ACT. We know of someone who shared to us that she was practically staring blankly for several seconds at a question very similar to this before it dawned to her how simple the solution was. It was a classic facepalm moment. Her words, not ours. Let's see if you agree that this question deserves a facepalm moment. 3p minus 2 is equal to or greater than 1. Recall that, except for a few exceptions, we simplify and solve inequalities in fairly the same way we do equations. The instinctive next step for many is probably to add 2 on both sides of the inequality. That's not wrong, and they'll probably get to the correct answer eventually. But let's try something else. Instead of adding 2 on both sides, let's add 4. Why do we do that? Well, you'll figure out why soon enough. By adding 4 to both sides we will end up with 3p plus 2 is equal to or greater than 5, correct? Wait, isn't the question asking us for the least possible value of 3p plus 2? And here we are already staring at 3p plus 2 is equal to or greater than 5. We can literally pick the answer from here. Therefore, 5 is the least possible value of 3p plus 2. Did you follow? Question number 25. Solve, 1 plus 2 plus 3 plus 4 all the way to plus 1,000 is equal to? A. 55,000. B. 99,000. C. 499,500. D. 500,500. The correct answer is D. 500,500. In this question we are being asked to add all the numbers from 1 to 1,000. Don't ever attempt to manually add all the numbers from 1 to 1,000, even with a calculator, or you'll end up getting the correct answer for this question, possibly, but with no time left to answer anything else. This requires just a little bit of analysis and some common sense. Let us, for a moment, exclude the last number, which is 1,000. So our last number must now be 999. If we pair 1 with 999, 2 with 998, 3 with 997, and so on, we should have our last pair as 499 and 501 and end up with a middle number, 500, without a pair, correct? If we add each pair of numbers, all of them will have a sum of 1,000. From 1 to 999, we should have 499 pairs of 1,000. 499 times 1,000 is equal to 499,000. We add to it the pair less 500, so our sum is now 499,500. But wait, don't forget the 1,000 that we temporarily excluded earlier. If we add it to 499,500, then our final total should be 500,500. Math is so much fun, right? Question number 26. In the given figure, the x-coordinate of point A minus the y-coordinate of point B equals A minus 2, B minus 1, C 0, D 5. The correct answer is D, 5. We simply determine the x-coordinate of point A, which is 3. Next, let's get the y-coordinate of point B, which is minus 2. Subtract minus 2 from 3. Therefore, the answer is 5. Boring? Question number 27. If A over B plus A is equal to 6, what is the value of square root of the quantity A plus A minus 2B over B? A 2. B square root of 6. C 3. D 4. The correct answer is A 2. Difficult algebra problem? Nah. By now you should already know that there are no difficult questions in the SAT or ACT math test. There are only tricky ones. The expression inside the radical can be expressed as A over B plus A minus 2. But A over B plus A is already given as 6. Therefore we can rewrite the expression as square root of 6 minus 2. We simply simplify further and should quickly arrive at 2. Question number 28. Given the equation, 2 raised to the quantity x squared minus 6 equals 8, solve for x. A 2. B 3. C 6. D 9. The correct answer is B 3. This is a simple and typical math problem involving exponents in both the SAT and the ACT. Whenever we are asked to solve an algebraic equation where the variable is an exponent, or is in the exponent, the first thing to do is to try to find a common base. In this case, the expression to the left has a base of 2. Is it possible for us to somehow express the expression to the right, which is just 8, as an expression with base 2? Well, definitely. 8, of course, can be expressed as 2 cubed. That is, 2 times 2 times 2 equals 8. Now with a common base, we can simply cancel out the bases and equate the exponents. Our equation is now simply x squared minus 6 equals 3. From here we can already quickly solve for x and arrive at 3 as the correct and final answer. Question number 29. A coin was tossed 3 times. What is the probability of landing on tail at least once? A 1/2. B 3/4. C 1/8. D 7/8. The correct answer is D 7/8. You are most likely to encounter at least one problem involving probability and statistics in both the SAT and the ACT. When you do, it will most likely look like this one. Or something similar. Back to our problem, what are the possible scenarios? We can start with all 3 tosses resulting to heads, 3H. Next is 2 heads and 1 tail, 2H 1T. Next is 1 head, 2 tails, 1H 2T. Lastly, all 3 tosses can result to 3 tails, 3T. Which of the above scenarios will result to at least 1 tail? Actually, all the scenarios except for 3H will result to at least 1 tail, correct? Therefore, the probability of getting at least 1 tail and 3 tosses should be equal to the sum of the probabilities of all the possible scenarios minus the probability of getting 3 heads. Let's label this as 1. But what is the sum of the probabilities of all possible scenarios? It is 1, of course. Remember that all probabilities should always equate to 1. Let's label this as 2. And what about the probability of getting 3 heads? The probability of getting a head when you toss a coin is 1/2. Therefore, the probability of getting 3 consecutive heads should be 1/2 times 1/2 times 1/2, or 1/8. Let's label this as 3. Now we can substitute the values from 2 and 3 into our formula in 1. We should quickly arrive at 7/8 as the probability of getting at least a tail when tossing a coin 3 times. Question number 30. If 2x plus 8 equals 16, what is the value of x plus 4? A. 4. B. 8. C. 16. D. 20. The correct answer is B. 8. The typical solution to this is to first find the value of x and then add 4 to it. This is how most of us were taught to solve equation problems in Algebra 101. It is okay. As long as we do our algebraic transformations or transpositions carefully and correctly, this solution will definitely lead us to the correct answer. But here's a slightly faster solution that may save us a few precious seconds. Divide both sides by 2. This results to 2x plus 8/2 equals 16/2, which is the same as 2x/2 plus 8/2 equals 16/2. Do you see how this results to x plus 4 equals 8? Since we are being asked for the value of x plus 4, then we already have our answer. Do you agree that this solution would have saved you a few precious seconds? A lot of the problems in the SAT and ACT math tests are like this. Question number 31. Solve square root of 144 factorial divided by the square root of 143 factorial is equal to A. 1. B. 12. C. 24. D. 144. The correct answer is B. 12. Here's another algebra problem that appears harder than it actually is. What makes this seems difficult is the presence of both radical and factorial symbols. But the solution to this is really very simple and quick. First, express 144 factorial as 144 times 143 factorial. Second, since both numerator and denominator are square roots, put them both inside the same radical symbol. Third, now we can cancel out 143 factorial since they are like terms. We should be left with square root of 144, which is simply 12. Question number 32. 5 times a number is 135. What is 17 more than 6 times the number? A. 27. B. 168. C. 175. D. 179. The correct answer is D. 179. This is another very simple algebra problem. All it requires is for us to be able to express the worded problem into their equivalent equations. A word of caution though. This type of problems are as much a test of our English grammar skills as they are of our math skills. Let us carefully analyze how the problem is worded and express it into its equivalent equation very carefully. Okay, let's proceed. Let x be the number. Step 2. 5 times a number is 135. We write this in equation form as 5x equals 135, and from here we can already solve for x, which is 135 over 5, or 27. Step 3. 17 more than 6 times the number is? We can write this in equation form as 6x plus 17 equals. Step 4. Substitute x value into the equation in step 3 and solve the equation. 6 times 27 plus 17 equals 179. Our answer. Question number 33. What is the area of the shape above? A. 40 minus 4x square units. B. 40 minus 4x squared square units. C. 40 plus 4x square units. D. 40 plus 4x squared square units. The correct answer is B. 40 minus 4x squared square units. This geometry problem requires just a little bit of imagination. Imagine the figure to be a rectangle with its 4 corners cut out. The size, or area, of each cutout corner is x times x, or x squared square units, and there are 4 of them, so that is 4 times x squared square units. The area of the rectangle, including the cutout corners, that is, assuming the corners are not cut out, is 4 times 10, or 40 square units. Therefore, the area of the shape should be the area of the rectangle, 40, minus the areas of the cutout corners, 4x squared, or 40 minus 4x squared square units. Question number 34. When the positive integer k is divided by 7, the remainder is 6. What is the remainder when k plus 2 is divided by 7? A. 3. B. 2. C. 1. D. 0. The correct answer is C. 1. When the positive integer k is divided by 7, the remainder is 6. Let's assume a value for k that, when divided by 7, will have a remainder of 6. The smallest number that will satisfy this is 13, correct? 13 divided by 7 equals 1, remainder 6. What is the remainder when k plus 2 is divided by 7? So we substitute k with 13 and solve for k plus 2. We should quickly arrive at 15. 15 divided by 7 is equal to 2, remainder 1. Therefore our answer is 1. But wait! You may be wondering if the remainder of k plus 2 divided by 7 will still be 1 for values of k other than 13. Fair question. So let's go ahead and check to validate our answer. So aside from 13, what's another number that, when divided by 7, will have a remainder of 6? The next one should be 20, and then 27, and then 34, and then 43, and so on. You may go ahead and validate our answer by using other values for k. For as long as k divided by 7 will have a remainder of 6, k plus 2 divided by 7 will always have a remainder of 1. Question number 35. Calculate the derivative of the given function. F of x equals 4x cubed plus 2x minus 1. A. X squared plus 3. B. Minus x minus 1. C. 12x squared plus 2. D. 7x squared plus 3. The correct answer is C. 12x squared plus 2. We did mention earlier that calculus problems do find their way into the SAT and ACT from time to time, but very seldom. And that if they do, they are usually just very simple calculus problems. This is another type of calculus problem that may appear in the SAT or ACT. In this problem we are being asked to find the derivative of a given function. So let's do a quick review on derivatives. Whenever you are asked to calculate or find the derivative of a function using the notation or symbol f followed by an apostrophe and then followed by an x inside a parenthesis, it means that you are to find the first derivative of the given function with respect to x. If the notation is f followed by 2 apostrophes, then you are to find the second derivative. If f is followed by 3 apostrophes, then the third derivative. And so on. By the way, be aware that the first derivative is also sometimes denoted as y apostrophe, or dy over dx. To find the first derivative of a given function, follow these simple and straightforward steps for each term of the given function. Step 1. Get the exponent of the variable, multiply it with the variable's coefficient, and write it down as the new coefficient for the term, followed by the variable. Step 2. Subtract 1 from the exponent and write it down as the new exponent for the term. Step 3. In the case of terms with no variables, meaning constants, simply drop the term. To find the second derivative, simply apply the same exact steps on the resulting first derivative. To find the third derivative, simply apply the same exact steps on the resulting second derivative. And so on. Now to actually solve our given problem. Our function is given as f of x equals 4x cubed plus 2x minus 1. To get its first derivative. For the first term, 4x cubed, we get the exponent 3, multiply it with a coefficient 4, and get 12. We write 12 as the new coefficient of the term, followed by x. We then subtract 1 from the exponent, so 3 minus 1 equals 2. Our new first term should now be 12x squared. We apply the same exact steps on the second term. Multiply exponent, which is 1, to the coefficient, which is 2, to get the new coefficient. Subtract 1 from the exponent. 1 minus 1 equals 0. So the second term becomes 2x raised to 0. X raised to 0 is simply 1, so we simplify the second term further as simply 2. The third term has no variables, so we simply drop it altogether. Therefore, our first derivative is 12x squared plus 2. Calculus is no big deal, right? Question number 36. Evaluate logarithm base 3 of 27. A. 9. B. 3 cube root of 3. C. V. D. Cube root of 3. The correct answer is C. 3. Yes, logarithms do appear from time to time in both the SAT and the ACT. Again, don't panic. Just like with the other math problems in the SAT and the ACT, even if a logarithm problem does appear, you can generally assume that it is a very simple one. You just need to know your logarithm basics, of course. So let's do another quick review, shall we? This time, let's quickly review Logarithms 101. A logarithmic expression generally takes the form, logarithm base c of x equals y. You may use any other combination of variables for x, y, and c. You may even interchange their positions, for as long as you remain consistent with them. But what is a logarithm anyway? By definition, a logarithm is just an exponent. A logarithm is an exponent which indicates to what power a base must be raised to produce a given number. Using our basic logarithmic equation above, a logarithm is an exponent which indicates to what power yz must be raised to get x. Still confused? Let's write it down in exponent form and it will become crystal clear to you. Logarithm base c of x equals y is the same as z raised to y equals x. If you are still confused, let's just go ahead and solve our given problem, while keeping these logarithmic notations and relationships in mind. In our problem we are being asked to evaluate the logarithmic expression, logarithm base 3 of 27. Let's equate the expression to x so we have a complete logarithmic equation to work with. Remember that a logarithm is just an exponent. So let's express our equation as an exponent as we've done in our quick review earlier. Logarithm base 3 of 27 equals x is the same as the exponent, 3 raised to x equals 27. So now we can completely forget that this is a logarithm and just treat it as an exponent problem. That, by the way, is the key to solving most logarithm problems. Recall that when solving exponential equations, we must always attempt to find a common base number for our exponents. Since the left side has a base of 3, let's see if we can express the right side with the same base of 3. 27 is actually 3 times 3 times 3, or 3 cubed, so yes, 3 is our common base. Our exponential equation should now read as 3 raised to x equals 3 raised to 3. Since we have a common base, we can cancel out the bases and simply equate the exponents. X equals 3. And that's it. Our final and correct answer is 3. That's fast and easy, right? Question number 37. A line has a slope of -2 and passes through the point 5, 3. What is the equation of this line? A. Y equals -2x. B. Y equals -2x plus 10. C. Y equals -2x plus 13. D. Y equals 69x plus 420. The correct answer is C. Y equals -2x plus 13. There is usually at least one question involving slopes in every SAT math test. This is an example. To find the equation of a line given its slope and a point where the line passes, first we must recall the slope-intercept form of a line, which is y equals mx plus b, where m is the slope of the line, and b is its y-intercept. The slope is given as -2 and we know that the line passes through the point x equals 5 and y equals 3. We now substitute the x equals 5 and y equals 3 to our slope-intercept form of a line, after which we can now solve for the y-intercept b. 3 equals -2 times 5 plus b. B equals 13. Therefore, the equation of the given line is y equals -2x plus 13. Question number 38. What is the quadratic equation that has 8 plus I and 8 minus I as its solutions? A. X squared minus 16x plus 64. B. X squared minus 16x plus 65. C. X squared minus 16x minus 64. D. X squared minus 16x minus 65. The correct answer is B. X squared minus 16x, plus 65. We can understand why this can appear quite difficult to most test takers. First, in algebra problems involving quadratic equations, the quadratic equation is usually given and then we are asked to find the solutions. But this is the other way around. We are given the solutions, and then we are asked for the quadratic equation that will have produced said solutions. Second, the presence of the notation I means that this quadratic equation involves imaginary numbers, a topic that many seem unfamiliar with, or even those quite familiar with it find it a bit confusing. Nevertheless, like in any of the other SAT and ACT math problems we have presented so far, you can be assured that this is quite a simple and relatively quick problem to solve. Let's get on to it. What do we do when we encounter the typical quadratic equation problems wherein we are asked to find the solutions? That's right, we factor the quadratic equation. So in this case, since the solutions are already given, we just reverse the process. We express the solutions as factors of the yet unknown quadratic equation, and equate to 0. X minus, quantity 8 plus I, times x minus, quantity 8 minus I, equals 0. From here, instead of immediately proceeding to expand the factors, let's regroup them first as follows. Quantity x minus 8, plus I, times quantity x minus 8, minus I, equals 0. We now expand the factors, x minus 8 times x minus 8, equals x minus 8, squared. X minus 8 times I, equals x minus 8I, minus x minus 8 times I, equals minus x minus 8I, and lastly, I times minus I, equals minus I squared. X minus 8I should cancel out because the second one is preceded by a negative. We're left with quantity x minus 8, squared, minus I squared. We expand x minus 8 squared into x squared minus 16x, plus 64. Meanwhile, by definition, I squared is equal to minus 1. We simplify further and we should eventually arrive at x squared, minus 16x, plus 65, equals 0. And that's the quadratic equation for our given problem. Question number 39. Which of the following has the greatest value? A. 2 minus the absolute value of minus 4. B. The absolute value of minus 2 times the absolute value of minus 3. C. Minus the absolute value of 12, plus the absolute value of minus 3. D. The absolute value of the quantity 1 minus the square of minus 2. The correct answer is B. The absolute value of minus 2 times the absolute value of minus 3. Let's quickly evaluate each answer choice. Answer choice A, 2 minus the absolute value of minus 4 is 2 minus 4, which is equal to minus 2. Answer choice B. The absolute value of minus 2 times the absolute value of minus 3 is 2 times 3, which is equal to 6. So between A and B, we can already eliminate A. Answer choice C. Minus the absolute value of 12, plus the absolute value of minus 3 is minus 12 plus 3, which is equal to minus 9. Between B and C we can also eliminate C. Answer choice D. The absolute value of the quantity 1 minus the square of minus 2 is the absolute value of 1 minus 4, which is equal to the absolute value of minus 3, which is 3. Between B and D, B is still the larger value, so the answer is indeed B. Question number 40. In the figure above, B equals A. 15 degrees, B. 20 degrees, C. 25 degrees, D. 30 degrees. The correct answer is D. 30 degrees. This is another too simple problem that we don't even find the need to explain our solution. 5b and b add up to 180 degrees. So we'll have 6b equals 180 degrees. From here we simply and quickly solve for b, which is 30 degrees. Question number 41. Michael is 3 less than twice the age of Janet. How old is Michael if Janet is 16 years old? A. 13. B. 29. C. 32. D. 33. The correct answer is B. 29. This must be one of the simplest age problems we've seen. It is so simple it doesn't even necessitate using the age table, which we generally recommend to use in solving any and all age problems. We don't even need to assign a variable, such as x, to denote any of the ages. Age of Michael is simply 2 times 16 minus 3, which is 29. Got it, right? Or maybe we'll explain a little. Janet's age is given as 16. Michael is 3 less than twice the age of Janet, so we multiply 16 by 2 and then subtract 3 from the product. The result is Michael's age. Note, if you wish to practice solving age problems of varying and increasing degrees of difficulty, we recommend you check out Review Central's mathematics drills featuring age problems. You should easily find it on our channel when it becomes available, if it isn't yet. Question number 42. What is the sum of the marked angles in the given figure? A. 270 degrees. B. 360 degrees. C. 540 degrees. D. 720 degrees. The correct answer is C. 540 degrees. Simply recall that the sum of the interior angles of any 5-sided polygon is 540 degrees. You should memorize the sum of the interior angles of your most common polygons, at least up to 6 sides, that is, triangle or 3-sided is 180, quadrilateral or 4-sided is 360, pentagon or 5-sided is 540, hexagon or 6-sided is 720. But what if you can't really recall the sum of interior angles of your common polygons? Better still is to memorize the formula for computing the sum of the interior angles of any n-gon instead. Here it is. Sum of interior angles of any n-gon equals 180 degrees times the quantity s minus 2, where s is the number of sides of your n-gon. So for our given figure, s equals 5. Therefore, the sum of its interior angles is 180 times 5 minus 2 equals 180 times 3, or 540 degrees. Question number 43. In the given figure, if cosine theta equals 3 over 5, what is the value of cosine 90 minus theta? A. 3 over 5. B. 3 over 4. C. 4 over 5. D. 5 over 4. The correct answer is C. 4 over 5. This is where your mastery, or at least a working knowledge, of SOHCAHTOA and some basic trigonometric identities can come handy. Given that cosine theta equals 3 over 5, from SOHCAHTOA we can determine the lengths of the sides of the given triangles. The length of the adjacent side is 3, and the length of the hypotenuse is 5. With 3 as the length of the adjacent or the shorter leg, and 5 the length of the hypotenuse, this is obviously the most common Pythagorean triple, the 3, 4, 5 right triangle, see image. From our trigonometric identities, we recall that cosine 90 minus theta is actually simply equal to sine theta. Again, with the lengths of the 3 sides of our triangle already known, and using SOHCAHTOA, we can simply find the value of sine theta to be 4 over 5, that is, opposite over hypotenuse. Question number 44. Find the product of the following fractions. 1/4, 2/5, 3 over 6, 4 over 7, 5 over 1, 6 halves, and 7 over x. A. 1 over x. B. 1 over 8x. C. 3 over x. D. 4 over 9x. The correct answer is C. 3 over x. Here's another seemingly complicated but actually very simple problem. Multiplying all the given fractions, we should quickly realize that most of the numerators and denominators can cancel each other out, leaving us only with 3 over x, which is the correct answer. Question number 45. A quality control manager at a factory selects 7 light bulbs at random for inspection out of every 400 light bulbs produced. At this rate, how many light bulbs will be inspected if the factory produces 20,000 light bulbs? A. 500. B. 450. C. 400. D. 350. The correct answer is D. 350. This is a simple ratio and proportion problem. Let's set up the ratio and proportion based on the given values. Let x be the total number of light bulbs inspected. 7:400 is equal to x is to 20,000. Solving for x, we should quickly arrive at 350 as our correct answer. Question number 46. For 5 consecutive odd integers, the sum of the first and third integer is 19 less than 3 times the fourth integer. What is the fifth integer? A. 5. B. 9. C. 11. D. 13. The correct answer is D. 13. This is another complicated sounding, but in reality very simple algebra problem that often appears in the SAT and the ACT. We have 5 consecutive integers, so if we let x be the first and smallest of the odd integers, x plus 2 must be the second odd integer, x plus 4 the third, x plus 6 the fourth, and x plus 8 the fifth. The sum of the first and third integer is 19 less than 3 times the fourth integer. Let's write that as an equation. X plus 4 is equal to 3 times x plus 6 minus 19. We then solve for x and should quickly arrive at x equals 5. We are being asked for the value of the fifth integer, which is x plus 8. Substitute the value of x, which is 5, x plus 8 equals 5 plus 8 equals 13. Question number 47. In the figure shown above, what is the value of x? A. 12 centimeters. B. 20 centimeters. C. 24 centimeters. D. 36 centimeters. The correct answer is B. 20 centimeters. Don't be fooled by this seemingly complicated figure. This is another very easy problem to solve. Since the steps are shown as right angles, we can assume that the resulting imaginary triangle from the projection of the leftmost vertical line and the bottom horizontal line is also a right triangle. We can easily figure out the lengths of the base and height of the imaginary triangle as 16 centimeters, that is, 4 plus 4 plus 8, and 12 centimeters, that is, 4 plus 4 plus 4, respectively. X is the hypotenuse of the imaginary right triangle, and we can compute it simply using Pythagorean formula, where the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the two legs. X squared equals 12 squared plus 16 squared. Therefore, x equals 20. Question number 48. Using the same figure as in 47, what is the area of the given figure? A. 96 square centimeters. B. 64 square centimeters. C. 48 square centimeters. D. 36 square centimeters. The correct answer is C. 48 square centimeters. This presents a different but equally easy problem to solve, much easier than it looks and seems. To solve for the area of the given figure, we simply solve for the area of the imaginary triangle and subtract from it the area of the imaginary L-shaped figure. Do you see it? The formula for the area of a triangle is 1/2 times base times height. For our imaginary triangle, the base is 16 centimeters, that is, 8 plus 4 plus 4, and the height is 12 centimeters, that is, 4 plus 4 plus 4. Therefore its area is 1/2 times 16 times 12, or 96 square centimeters. How do we compute for the area of the imaginary L-shaped figure? By using our imagination a little more, that's how. If you look closely, you can easily see that the L-shaped figure are actually 3 squares, with 2 squares side by side each other, and another one on top of the other. Can you see it? Now, all 3 imaginary squares have a side 4 centimeters long. Therefore, their total area must be 3 times 4 squared, or 48 square centimeters. We already determined earlier that the area of the figure is equal to the area of the imaginary triangle, minus the area of the imaginary L-shaped figure. Therefore, the area of the figure is equal to 96 minus 48, or 48 square centimeters. Question number 49. Solve the given nested radical, square root of, square root of, square root of, square root of 2, which is then raised to the 48th power. A. 8. B. 64. C. 256. D. 4096. The correct answer is A. 8. This looks very complicated, right? Not really. The only real challenge here is to make sure we correctly count the number of radicals used in the problem. That's where we can potentially commit a mistake. If we miscount the square root symbols, then we'll surely arrive at a wrong answer. Okay, now let's solve this together, shall we? Rewrite the outermost radical as the exponent 1/2. Our radical expression should now read as square root of 2 raised to 48 over 2, or square root of 2 raised to 24. Now we only have 3 nested radicals left, correct? Repeat for the second, third, and fourth radical. The exponent should therefore progress from 24 over 2, to 12 over 2, to 6 over 2, which is equal to 3. At this point the expression should have been reduced to 2 cubed, which is simply 8. Question number 50. In the figure above, O is the center of the circle. Line segments AC and AB are tangents of the circle. Find X. Note that the figure is not necessarily drawn to scale. A. 120 degrees. B. 130 degrees. C. 150 degrees. D. 170 degrees. The correct answer is B. 130 degrees. Let's focus our attention to the kite, or quadrilateral ABOC, formed by the 2 tangent lines from A, and the 2 radii from the center of the circle. By definition, the interior angles of any 4-sided polygon should equal to 360 degrees. From the figure, angle A is given as 50 degrees. Angles B and C must be both right angles or 90 degrees each, since by definition, any line that is tangent to a circle is perpendicular to the radius of the circle at their point of intersection, which is at the point of tangency. Therefore, angle X is simply equal to 360 minus the sum of angles A, B, and C, or 360 minus the sum of 50, 90, and 90 degrees. That's 360 minus 230, or 130 degrees.
Question number 51. This is a bonus question. If 3x minus 5y is equal to 2, what is 8 raised to x over 32 raised to y? A. 1. B. 2. C. 4. D. 8. The correct answer is C. 4. Express 8 raised to x over 32 raised to y, as 2 raised to 3 raised to x, over 2 raised to 5 raised to y, which we can simplify into 2 raised to 3x, over 2 raised to 5y, and still further simplify into 2 raised to the quantity 3x minus 5y. But wait, 3x minus 5y is already given as 2. Therefore, we can further simplify 2 raised to the quantity 3x minus 5y into 2 raised to 2, which is of course equal to 4. That is way too easy, don't you think?
You have just completed the penultimate SAT and ACT Cram-Time reviewer for mathematics. If you wish to watch more SAT and ACT mathematics reviewers, check out our SAT and ACT mathematics reviewer playlists. Check out also our other SAT and ACT reviewer playlists for other reviewer topics. If you haven't done so yet, please don't forget to subscribe to Review Central and click or press the bell button to make sure you get notified whenever we post a new reviewer or other review materials on this channel. Please like if you find this video useful, and feel free to share it to anyone who may also benefit from it. We wish you all the best on your forthcoming SAT and/or ACT test, and A for fun and fulfilling college life in the US. Good luck.